Pre-Calculus Chapter 4, Lesson 3, and I want to do some examples where we evaluate these trig functions given these different types of angles. So I'll do a number of problems, and as always, you watch as many as you feel you need to watch that makes you helpful or would be helpful to you, and then we'll go from there. Now, again, as we've talked about, is with these coterminal angles, if the terminal side is coterminal with one of our special triangles, our 45-45-90 or 30-60-90, and the trig ratios are the same for any of those, we can simply use our knowledge of the 30-60-90 and the 45-45-90 to determine the trig value of any function as long as we know which angle we're talking about or which triangle we're talking about. So, for example 1, we're asked to find the cosine of the angle, and the angle is a 570-degree angle. Now, the nice thing about this angle is they've already drawn it for us. Because it's negative, we're going clockwise, so we go once around the circle, that's 360 degrees. Another 180 would be 540, so what's left here is 30 degrees. So I'm going to draw my reference triangle, and we always go to the x-axis, so that means that this angle here is a 30-degree angle. So that's a 30-60-90. So in a 30-60-90, we know that the smaller side opposite 30 is a 1. The side opposite the 60 is radical 3, and because it's left here, it's negative, so this is negative radical 3, and the hypotenuse is 2. So to write the cosine ratio then, I simply take the adjacent side, which is negative radical 3, over the hypotenuse, which is 2, and you can see that's my trig ratio. The other way, or just to kind of piggyback on what we've been learning about, the coordinate of this point then is negative radical 3, and then up 1, and then the r value is a 2. That's the length of this side here. So the cosine is related to the x value, so that would be the x value of negative radical 3 over 2, which again is my cosine value. Okay, so let's go ahead and do another one. We'll look over here at number 2. And at number 2, again, we're asked to find the cosine, and again, the angle is a 630-degree angle. So again, as we start here at the initial side, we rotate once around, that's 360. Another 180 is 540, and then another 90 puts me at 630, so I'm on a quadrantal angle. So what we do here, remember, is we choose this r value to be 1. So the r value is 1 because we're going to make this distance 1, and the coordinate of this point then is 0, negative 1. And now we can do the cosine, which is the x value of 0 over the r value of 1, 0 over 1, or 0. So the cosine of this is 0. Now, hopefully you're starting to make the connection here that when we're on a quadrantal angle, we really don't even need to worry about this r value because we know that the cosine function is going to end up being this x value, whatever it is, because it's over 1. And the sine values going to end up being this y value because it's going to be over 1. And then the tangent function and cotangent are simply the y over the x or the x over the y. Okay, let's look at the secant function down here. So we have the secant of a 45-degree angle. That's nice and easy. We draw our reference triangle down here. In a 45-45-90, we know these are both 1 and it's square root of 2. We're in quadrant 1, so both are positive. The secant, you remember, is the reciprocal of the cosine. If the cosine is adjacent over hypotenuse, then the secant would be the reciprocal, or the hypotenuse over the adjacent, which would be radical 2 over 1, which is radical 2. Again, if I understand this coordinate at this point is going to be 1, 1, and the r value is negative 2, or I'm sorry, square root of 2. So the secant is the r over the x, or radical 2 over 1. So again, you can see that we can do this rather quickly with these coterminal angles that are coterminal with our special right triangles. I'll do one more of this variety, and then we'll look at something else. Let's look at one that maybe looks a little bit challenging. Let's look at this cosecant one here. Cosecant 1, now here is negative 120. Now be careful here because the tendency is always wanting to go the shortest distance, and you're going to want to make your triangle here, but that's going to throw everything off and everything's going to be inverse of what it should be. So we've never done that, so don't start doing that. We have always done, and we've always said, that we draw our reference triangle going perpendicular to the x-axis. So you always have to go here. So if this is 120, now I need to know this angle because this is the angle that's in the triangle. So if this is 120, then what's left is going to be 60. Okay, so that means this is my 30, so opposite the 30 is the shorter, so this is going to be my 1, and because I went left, it's negative. I'm going down, so that also is negative, and it's the longer, so that's radical 3. And then the r value is going to be 2. Now the cosecant is the reciprocal of the sine, and the sine being opposite over hypotenuse, so the reciprocal of that would be hypotenuse over the opposite. And again, then we're going to rationalize this denominator because our final answer should never be left unrationalized. So that's going to be 2, negative square root of 2, I'll get it, negative 2 over square root of 3, all of that over 3. So we have our trig value evaluated. Okay, let's look at ones now where they don't give us the angle, so we have to draw our own reference triangle and our own angle. So we're going to want to be able to do this. Now, very quickly, sine of 90, that's pretty easy. A 90-degree angle is here, so that's a quadrantal angle. And because this is an r value of 1, the coordinate of this point is 0, 1. The sine is related to the y value, so the y value is 1, so I have a sine of 1. If I have a tangent of a negative 270, negative 270, well this would be 90, 180, and one more here would be 270. So again, we're on a quadrantal angle. An r value of 1 gives us this coordinate of 0, 1. And the tangent, you remember, is the y value over the x. So that would be 1 over 0, which is undefined. So we have an undefined value here. Okay? Let's do one more that's kind of this difficulty here. Let's do this one here. Cotangent of 240. Okay. Now, 240 means I'm going counterclockwise. Now, I know that, well, there's a couple ways to look at this. I know that all the way to here is 270, so 240 is going to be 30 short of that. So I'm going to be in this quadrant. And if this is 30, then this is going to be 60. Or I think that this is 180 and then another 60 is 240. So I draw my reference triangle. This is a 30, 60, 90. This is the 30, so this is the shorter side. This is the longer side, and then this is my r value. Now the cotangent is the reciprocal of the tangent. The tangent is y over x, or opposite over adjacent. And so cotangent would be adjacent over opposite. So the adjacent here would be negative 1 over the opposite here, which is negative square root of 3. I have two negative values, which makes it positive, and I want to rationalize this denominator, so I get a positive radical 3 over 3. So for this example here, let me get the instructions up here so we can see what we're supposed to do. We want to use the point that they give us on the terminal side to find the trigonometric function that's given. Now you remember, if we just from this point draw a line perpendicular and draw our reference triangle, then we have this side as the square root of 11, and we have this side as 5, and I need to do the secant. The secant is the reciprocal of the cosine, and the cosine is the adjacent over the hypotenuse, so I need to know this hypotenuse. So I'm going to have to use the Pythagorean theorem to determine this, and then I'll be able to write my ratio. So I need to use the square root of 11 squared plus 5 squared is going to give me my r value squared. So if I square the square root of 11, that's 11, and then 25 squared is 25, and then if I take the square root of that, that's going to give me r. So this is going to be the square root of 36, which is 6. So this is a value of 6. So now that I have my sides determined, I can do the ratio. Again, secant is the reciprocal of the cosine. So the cosine, remember, is x over r. So here, the secant would be r over x. So it's going to be the r value of 6 that I just determined over the x value of square root of 11. I'm going to rationalize that denominator, which gives me 6 square root of 11 over 11. All right. Let's do this cotangent one over here. So I'm given the value 4, 3. Again, I draw my reference triangle. This is 4, this is 3. In order to use the cotangent, that's just the reciprocal of the tangent. The tangent is y over x, 3 over 4. So the cotangent would be the reciprocal of that, x over y, 4 over 3. Now the nice thing about tangent and cotangent is if you know the x and y value, you don't need to know the r. So you really don't have to determine anything. You can look right at the ordered pair and determine that trig ratio rather quickly. Again, tangent being y over x, cotangent being x over y, the reciprocal. All right, just a couple more examples and then we'll wrap this up. Which one looks most difficult? I don't know. Let's do the ones with the radicals. So I'm given the x and the y. I'm asked for the secant, so I'm going to draw my reference triangle. So this is 5. This is the square root, negative square root of 11. So the secant, again, is the reciprocal of the cosine. The cosine is x over r, so I need to know r, and so because the secant would be r over x. So again, we'll use Pythagorean theorem to determine the value of r. So this is 5 squared plus negative square root of 11 squared. That's going to give me r squared. So again, this is 25. Square root of 11 squared, or the negative of that, is a positive 11. So square root of 36, which again is 6. So r is 6. So the secant is the r value, which is 6, over the x value of 5. Okay? We'll do one more. We'll do this example down here. It looks a little bit challenging, but I think we're pretty much up to the task right now. So I'm given these 2 points. So we're asked for the cosine. So again, this is negative 15, drawing my reference triangle, and this is negative 5. Cosine is the x value over r, so I need to figure out what r is. So I'll use Pythagorean theorem. So negative 15 squared plus negative 5 squared, and if I take the square root of that, that's going to be r. So 15 squared is 225, and negative 5 squared is 25. So I'm looking for the square root of 250. Well, that's pretty tricky. What's the square root of 250? Well, that's actually 25 times 10 would be still 250, and the square root of 25 is 5, so that simplifies to 5 square root of 10. So my r value is 5 times the square root of 10. So now that I have my values determined, I can figure out the ratio that they asked me for. So the cosine again is the x value, which is negative 15, over the r value, which is 5 square root of 10. Now I need to do some simplifying here, so a couple ways to go here. I'm going to simplify this first. So that's going to be 1 and negative 3. So that's going to be negative 3 over square root of 10, and then rationalize my denominator. So that's going to be negative 3 square root of 10 over 10. Okay, so not too difficult. If you draw your reference triangle, draw your terminal side, determine the values of the sides missing using Pythagorean theorem, and then everything else is pretty much, well, I'd like to say easy, but I get in trouble when I say easy. But given that information, if you follow all that, I think you'll do fine.